Okay, just, yep, I can start now, correct?
Yeah, sure. So let me maybe introduce you a little bit.
Okay.
So Sean Joseph is a data engineer at Elliott Ward, speaker, blogger, data-driven community builder, founder and May organizer of Cloud Data-Driven User Group and Future Data-Driven Summit. So Sean, over to you.
Right. Thank you so much, guys, for the opportunity. And thank you so much for tuning to my session. Yeah, and welcome everyone to GroupBy 2021. Our agenda for today is how to troubleshoot SQL Server database performance issue. And I know this is a huge topic. Everybody have their own way they're doing it. I guarantee you at the end of the session, you must be able to maintain your environment the way you should, if you haven't. Who am I? I'm Jean-Joseph, currently working as a data engineer. I started as a network administrator while working with database team. I love how they do things, and I moved to database administration and development. While supporting data science team, I moved to data engineering. This is my LinkedIn code. If you guys wanna connect with me on LinkedIn, fine, you guys can scan it and let us connect it. Why not? Why not? As they already introduced me, I don't have to repeat exactly what have been said. Yeah, I'm from New Jersey and originally from Haiti. Today, I'm going to show you different ways to troubleshoot your environment and explain to you common causes of performance issue and what metrics to monitor. Performance start from scratch. What I have seen people doing, they most likely care about adding indexes, updating statistic, or they want to master the query plane, the query optimizer, but they forgot the configurations. When it comes to performance, the way you configure your instance and your database can impact your performance. What I would suggest you to do is after you install or configure SQL Server, it would be best to enable optimize for ad hoc query. The second one is main and max memory. It would be great to configure this because when it comes to memory or any kind of resources, SQL Server, especially for memory, SQL Server is very greedy. It's gonna get until the operating system will not be able to breathe. So it's always best to limit that. And also for max degree of parallelisms, when your processes are running in parallel, it's true you may gain performance, but sometimes that can cause some performance issue. And then do not use the default. It's always best to configure it depending on the number of CPU or core available or depend on your workload. For cost ratio for parallelisms, the default is 5. This is too low. And then, yeah, this is the one that controls the behavior of max degree of parallelisms. For OLTP, I would highly suggest you to set it up between 40, like 30 to 40 or 40 to 50. For data warehouse, it would be great if you can pull it between 70 to 80. I don't think that there's going to be an impact. Actually, you may gain a lot of performance. Also, make sure you enable instant file initializations. So this will allow SQL Server to bypass the zeroing out in order to allocate the space. And then when it comes to power saving, it would be best to switch from balance to power plant high performance, unless if your workload depend on dynamic workload. This is not related to performance. However, for troubleshooting, it's always best to enable remote access connection. If things happen, you have to be able to connect, and sometimes dedicated admin is the only way you can connect. For backup compressions, by default, it is enabled, but sometimes I have worked for clients where, for example, they have their own dedupe third-party process, and then the storage people ask you to disable this. That sometimes can impact performance, because if you have 10 gig of database size, and then 10 terabyte, I meant to say, and then you're gonna back up all of that 10 terabyte. So you can see how long it's gonna take. However, compress it may speed up the process a bit. If you can control that from the compression from SQL Server, I think you may benefit a bit of performance. There is a backup with checksum. This is not related to performance, but this is related to page corruptions. Anytime if something happens, SQL Server, let's say if you are issuing a backup, there's any page corruptions, SQL Server, your backup will fail. So what happened, there's gonna be information SQL Server will send to MSDB suspect pages. For database setting, guys, it always best to leave always auto create statistic on and auto update statistic on. Sometimes, depending on the environment, if they're enabled, they can, slow down performance, because when auto create and update statistic that can slow down your process. But 95% of the time, I would highly suggest you to leave it enabled, as by default it is enabled. For auto shrink, I have worked for a company where they use a third-party software that force the production DBA to enable this, and that caused a lot of issue. Unfortunately, we couldn't do anything, because that the environment was belong to that client. But it's always best to leave it off, unless if there is a valid reason. We spoke now about page verification for checksum. This is at the database level. And then for AutoGrowth, it's always best to configure, to pre-configure AutoGrowth. The reason why I'm saying this, even though if you have instant file initialization on, you enable it, but when AutoGrowth kick in, that can impact performance a bit. So precise it can improve performance, because AutoGrowth will occur less depending on the environment, especially if you have OLTP that is not related. There is absolutely no batch processing, so that may be good. Even Microsoft realized how important is this, and during the installation, I think since 2016, Microsoft suggested change the 10%, I think, to 64 meg. I always configure my AutoGrowth between 512 megabyte or 1 gig, depending on the environment. So this was, for example, the server and database configuration. So now let's go to the data part, where we're gonna do kind of cool stuff, okay? For example, let's say, for example, you receive an email from reporting team. They say things are running slow. What they mean by slow, remember guys, information is the king. By the way, we working in IT field. IT by definition is information technology. Sometimes we need to know exactly what they mean by things are running very slow, right? But let's say if you call reporting team to understand what is the root cause of this issue, and then they share the screen with you. Let's go kind of normal, and then they told you this process used to run for at least 30 seconds. Now it is over 41 minutes, close to 42 minutes, and then we still haven't get any result. What would you do? What I have seen people done is that they quickly go rebuild index. When you're rebuilding index, this is a very expensive operation. I would not suggest you to go there first, and you're gonna see why. And then what I have seen people also doing is quickly modify the process before they do some deep analysis to see if the issue could be related to something else. Let's go back to our slide deck. Okay, so during the execution process, I'm gonna explain to you the execution query nodes. When a user, for example, or application, send a request to SQL Server receive that request. Okay, so a task created. If resources are available, what happened? SQL Server proceed with that request. So that means it is running. Running, if it means that SQL Server happy because resources are available. Okay. However, that doesn't mean business processes are happy. Business could face tons kind of issue like parameter sniffing, okay, which is related to tons of things like statistic outdated. That could be, for example, missing indexes. There could be index fragmentation. It could be bad query plan as well. And the underlying data may change, right? But however, SQL Server is happy, right? Let's say if the threads, not all the threads are available. So for some reason, SQL Server have to wait. When SQL Server have to wait, there are two stages. The first stage is that, so if you're looking at now, SQL Server have to wait. If, SQL Server kind of not happy. So the first stage is that if SQL Server are waiting on thread, if the process, if your process is waiting on thread to be executed, so that's when SQL Server is not waiting on nothing. The process is just waiting for it turns to execute. So when it turns to arrive, it's gonna change that and pull and change it to running. However, if SQL Server have to wait for something else, so this is where things get a little bit complicated, where your process has to be suspended. So SQL Server have to wait on something. When SQL Server is waiting on something, it could be anything. It could be, for example, page IO latch. Page IO latch, this kind of wait type capture, for example, when SQL Server is reading data. Pages from disk into buffer pool. If this wait type is one of your 5 or 10 waits you are frequently seeing on top of your production server, this tells you that you may have IO problems that is related to storage subsystem, or it could be also a memory issue. There are some other reasons, some other kind of with type like async network IO. Async network IO is normally a network bottleneck. Actually, it's indicate two type of network issue. One of them is pure network issue. The other one is a network problem that impact SQL Server performance. So negatively. So what I mean by impact negatively is that, let's say if you have an application, that application is sending huge volume of data, right? Than expected. So if your network cannot handle this, you will see this kind of with type. So what can you do to resolve this, right? Sometimes it's best to work with for an application, review the application and the data and see, for example, if you can break it down into smaller chunks. For example, if you can use pagination. Let's say when you go to Google, you type what would I say, SQL Server with type. They don't give you all the data all in once. You have page one that you can go. If you're not satisfied, you go to page two until you get what you need, right? So you can work with application development team and implement that as well. The other thing that can help you also is to check the network capacity that in between the client machine and SQL Server. For example, routers, and NIC, and sometimes even cable, because some customer kind of cheap sometimes. And then you can also work with operation team to validate the server NIC, and also make sure the latest driver has been installed as well. You can increase the packet size properties if you are using string like big XML data. There are some other with type that are kind of frequent, like page latch. Those type of with types, they are non-IO weights for latches, okay, on data page in the buffer pool. So what I mean by is that if you are seeing this a lot, these are related with allocation contention issue. For example, TempDB could be under pressure. You're seeing this, right? There are some other metrics like IO completions. There are white log. White log is that SQL Server write all modifications
I'm not sure if it's only me, but I think we lost Jean.
Yeah, I think it was just for a sec. I think we're coming back in now.
Hello?
Oh yeah, we can hear now again.
For
we lost you for like probably about 30 seconds.
Okay. Shall I go back or carry on?
No, I mean, if you just share your screen again, because you are not sharing right now due to probably a reconnection. And if you could just back like 30 seconds of what you were explaining, yeah, that would be great.
Yeah.
We can see your screen now. Thanks.
Okay, there is IO completion, and then there is, for example, page. There is, for example, white log. write log is that SQL Server write all the modification to the log buffer. So what happened if the size is bigger than 60K, and then that means the log buffer fill ups, and then you will see a lot of you will see this kind of wait type generated like white log, right? So what can you do to, for example, resolve this? You can put the data file and the log file into different drive. You can increase the I/O capacity on the disk of the disk.
Ajin, I think you might have to keep your camera off just for bandwidth there. We're losing you on that part. Hello?
Jean,
Is it
can you hear us?
same thing?
Yeah, I think we might be
Is it
losing you
same
with,
thing?
yeah, it's the same as before. Maybe try without your camera on and see if that improves stability a little bit.
Yeah.
Okay. Let me see that. Let me turn that off. Give me a second. Is it better now?
We see.
Yes,
it was
I'm
fine.
sorry
It was
for
fine
that.
for a few minutes, yeah, and then
Yep.
we get you lost again. But yeah, now it's fine.
Perfect. So now there is CS packet. CS packet is not a good indicator that we have in CPU pressure. However, it can be a good way to do some other analysis, because a lot of things can generate this kind of weight type. Like if your statistic is not updated, if there is missing or fragmented indexes, and sufficient memory, CPU pressure, there's cardinality estimator version as well. That can be an issue. And then if you only configure your maxed up, that can cause this kind of weight type, not only the maxed up, and even the cost threshold for parallelism options. If you did not configure this properly, that kind of weight type will show up, like CS packet. There is also thread pool. Thread pool is that it's caused by a lack of available threads. This can occur in periods of high CPU utilization, especially when there is heavy parallelism is involved, right? Like if there are a lot of blocking, excessive database meanwhile, or even availability go, right? The best way to troubleshoot this is to use profiler extended event to determine what causing this, right? And then there's other ways you can do it, like you can decrease the number of that database meanwhile, or even the AG, but this might kind of the right way to do it, or you can optimize your parallel queries. And then there is a SOS scheduler here. This is something that is typically indicate you may be under CPU pressure. Okay, so what happened if the processing of the thread is not completed? And for example, all resources are available state for this thread. What will happen? SQL OS will move that thread to the runnable queue and wait to reprocess it. So this is exactly, so if you're having this, you may be under CPU pressure definitively. So what can you do to resolve this? First of all, You need to identify and optimize query which consume high CPU. Add more CPU can be one of them. And then also, if you have page compression enabled, so that can cause this issue as well, right? So ensure you have enough CPU for that if page compression is enabled. And then also, for example, having a good index maintenance in place, you know, at non-peak time can help you with this. There is lock, and you guys know lock, and I have a tons of demo for this. We're gonna go over that. And then also there is OLEDB. Wait, there's a tons of them, and we can't even count. These are kind of few, just to show you when things happen, you cannot only rely on indexes, you cannot only rely on update statistic, query plan, but there are so many things you can think of. But there is another thing I have seen people minimize. 80% of the time, this can be a performance killer, which is like a sleeping session with on old open transactions. So if you're looking at, let's say if someone, I have worked for clients where, for example, business have the same level of access on top of production, they go, they do anything they want, and there is absolutely nothing you can do, right? Because that's the way it's been there forever. They may start a process, they're updating production database because they are 100% sure, you know, the data will be accurate. So if the process might take 5 to 10 minutes, they may step out and then grab a cup of coffee. And then let's say if they probably even forgot, and then that can cause issue. In this case, it doesn't matter if your process is well tuned, there's absolutely nothing you can do, because sometimes not everything is related to the database. Not all the performance issue you will be able to resolve. That's why come up with a strategy to understand the root cause of the issue would be better for you. So now, for example, these are everything we have seen. Let's go to our demo. First of all, how I'm gonna start, okay, I see this. The first thing I'm gonna do before I do anything is to take a snapshot, for example, of the environment. As you can see, I normally document this. Give me 1 second. I always take a snapshot of the environment because I don't want anything from my script showing up. Yep. So I normally quickly take a snapshot. So I have this, but consider this as your Excel sheet. And then the second thing I'm gonna do now. So I have a snapshot of the environment. I will check to see the number of connection first, okay? So because this is gonna take a second, I can quickly see this is not a busy environment. So now I'm gonna see, okay, the type of connection, and then, yep. So here I can quickly see, okay, the kind of programs that connected to my environment. So now I have a good idea, and this have to be documented because, yep. So now I have a good idea. The third thing I'm gonna do is look for blocking. Do I have something? Okay, I have 2 processes that are being blocked. I can see that they are being blocked for by 61 and 63. So now I can clearly see there is blocking. What I'm going to do now is check for open transaction before I go ahead and do anything. For some reason, I'm not sure why this is taking that long. Yep. Yep, I'm not sure why this is taking that long. Yep. So now, oh, sorry guys. The system slowed down on me. I'm going to check to see if I have open transaction. Sure enough, I have 2 open transaction. If you're looking at here, and then if you're looking at here, they are sleeping. They are not doing nothing. So that's when if you're executing a process, you ignore those can be one of your performance killer. Okay. So now I can go a little bit deeper to get, for example, more information. And I want to give credit to whoever created this script. Okay. So now, I need to get more information. Okay. So now I can see the plan. I can see the query. So now what I'm going to do is to get information about the blocking session. This is 61. For some reason, my system is very slow. This is, give me a second. This is 62. And then this is 64. Sorry, this is 61. And then this is 63. Okay, if I execute this, I can quickly see the query that was executing. I can see both of them have began trend. I can see the login name and the host name, where it's coming from. Now, because I have documented this, okay, so I can quickly see kind of the tree, what was going on. Let me show you this one. If I execute this now, I will get all the information. I can see, for example, 61, start a process, okay? So that's mean there is an open transaction with no commit or rollback. And then that's the time 62 request that same set of data. And then because there is a lock, 62 have to wait. I can clearly see, for example, 63, if you're looking at the time, you will see it is in order because I ordered by last batch. That doesn't mean this is something guaranteed, but sometimes it works for me. Okay, so if you're looking at, I can see 63 did the same thing, but didn't commit his transaction. Okay, for some reason, the system is very slow today. Okay, so now, and 64 happen to request the same set of data, right? So that's mean in this case, it doesn't matter how knowledgeable I am when it comes to performance tuning. It doesn't matter, for example, how well I tune my environment. There's absolutely nothing you can do to resolve this. Sleeping open transaction, you need to monitor for that. Actually, when I used to be a production DBA, I always have a process to alert me whenever there is a session that is completed with an old open transaction more than 15 seconds, because I need to be aware before business realize something is, kind of going wrong. And then the reason why I have created that snapshot is that sometimes if I create this, you will be able to see all kind of script I execute to troubleshoot. That's why I always start from scratch. Yeah, take a screenshot. So this is one way, for example, you can see sometimes knowing how to start may help, but if you don't know exactly where to start, that's gonna be a great way to start. Remember that sleeping session with open transaction can be sometimes very challenging. Okay, so now I think this is one of the demo. Let me move to my next demos. For some reason, this is taking so long. I'm not sure why my system let me open it then. Let me go straight to my next demo. Can you guys hear me?
Yeah, we can hear
Okay,
very well.
perfect. Let me go to my next demo. For example, if you're looking at statistic also.
You know that you have the other query session 62 still running. Yeah.
Let me.
You're aware of that.
Yeah. I was trying to, close them, but for some reason the system was slowing down on me.
Maybe from the other window, try to use kill. Oh, okay, it's closed.
Yeah, it is closed. Yep. So this is statistic. I'm about to show you one of the best way to troubleshoot statistic. If you're looking at this one, I'm about to create a database and call it GroupBy. And I'm creating a table and I'm inserting, for example, records into that table. Okay, perfect. So now, for example, when you create a table, there's absolutely no statistic. Okay, even though if I select that table, there's I select all the data, there's absolutely no statistic. Statistic will not create. Let me show you something. If I query this one, you will see there is no statistic. However, yep. However, if I query this one and I execute the same one, you will see there is statistic created. I was able to get statistic. This is the exact number that I inserted, if you remember, correct? So now I have my statistic there created. Let me show you something. The normal way I have seen people troubleshoot statistic, they use this one, which is DBCT show statistic. True enough, you can see, for example, I see the last time it is being updated, the number of rows that is being affected, correct? If I make a select count and group by city, you will see, true enough, everything match. For example, there is one row for Bala. If I check for Bala, you must see, for example, 213. Let me see. This is B Venton. Okay. If you're looking at this one, you will see, for example, statistic are correct. Whenever you create an index, the index automatically generate and create a statistic as well, carry with the same name. Okay, you can see that start same row and then same information. And if I do a count again, you will see same. But the reason why I really don't like this, if I need to get information regarding the underlying object, I will need to have multiple statements for this one, correct? However, this DMVs, the reason why I love it is that if I pass the object, I can see, for example, if my statistic match, we can clearly see, right? If you're looking at here, the modification is 0. Just pay attention. You see, it is 0. I'm about to insert 832 records. Let's see what will happen. Okay. I just insert 832 record, as you can see, correct? If I rely on this one, let me show you. If I rely on this one, you will see what will happen. My numbers still remain the same. What about my 832 record that I just inserted? Okay. So that's mean if you want to troubleshoot performance issue and you think it is statistic issue, if you are using DBCC statistic, the only thing you can rely is on this one, for example. If you rely on update statistic, you may be getting the wrong information. Let me explain it to you. Let me go and see if London and city have the same numbers from statistic as we just inserted. Can you hear me? Hello?
Yeah, we can hear all the time.
I see my internet drop. Can you guys hear me?
Yeah, we can hear you. We are fine. Can you hear me? Hello, Jean? Can you hear me? We still can hear you. I'm not sure. Oh, something happened with your VM, but we still can see your screen. Can you hear me? Can you hear me, Jean?
Can you hear me?
Yes.
Okay, perfect. Can you see my screen?
Yes, now we can see your screen.
Perfect. If I check for London and Paris, we will see, for example, if statistic is really updated. If you're looking at London is 834. However, we have insert the data. If you remember here, we have inserted. And then if we check for Paris, give me a second, the system. If you're looking at for Paris, you can see Paris is not updated as well. So that's mean if you rely on DBCC, DBCC show statistic, you may get the wrong information. However, if you leverage, for example, we can skip this. Okay, let me go this way. Okay. If you leverage this, and then let me execute this. If you analyze, you will see, for example, it is the same record, but at least you can see you have 832 record that is modified. So that's mean you can clearly see something change. Let's say when reporting team say things are very slow, and then you check there were absolutely no blocking, there were nothing that can cause that issue. And then I think now you want to do some analysis against your environment. DB_start properties should be your best friend, because it's going to tell you the number of records that's being affected per object. And if you want to filter for a specific object, and then you can clearly see what is going on. Okay. So now, update statistic and see what will happen. Okay, let me update it. For some reason, the system is very slow. Yep, I update it. And then if I query the same thing again, okay, and then you will see modification is 0, and you will see exactly the number. Even if I check for DBCC show statistic, you will see it is still the same numbers. So that's mean this is great if you just need a quick information, but when it comes to troubleshooting, it would be best to use this view instead. Otherwise, you may end up to think things look good, but it doesn't in reality. Okay, so sometimes even the way you return your queries can impact your performance. Let me, for example, show you. And I want to say thank you to SQL Server, because I think I modified that script. It was a demo they have, and I like it. I said, let me add it. Sometimes being fancy, it's not really good because it comes with a performance. If you're looking at in this one, they use a correlated subquery to do this, okay? They're doing the sum total calculation the same way, using that subquery, even the discount, they're doing it. The same thing could have been done if you use a derived table. Let me show you. Because this is a very expensive query. Let me show you. So here I'm doing the same thing, but instead I'm using a derived table to do that. And I'm just calculating the duration. Let me execute it. So this way we can be on the same page. If you're looking at the first one, it takes 557 milliseconds, the first one. And then the second one, it takes, for example, 157 milliseconds. You can see just 20 rows return, nothing else, just 20 rows. You can see that much difference. For example, the way you code can impact your environment, right? I would highly suggest you, anytime when you think of correlated subquery, if there is a way you can use derived table, it would be better because you will definitively get better performance. Okay, and then let me go to my next demo. Sometimes even join and cursor, people that come from a C#, C++ background, when working with them, what I have seen, they are big fan of loops. They love loops for some reason. I'm not sure. If you're looking at this sample script, and I would love to say thanks to SQL Server as well. I modified this a bit. Yep, just to show you, I'm not cheating. I'm cleaning the cache, okay? So what I'm doing, I am putting this value into the memory and fetch into this in order for me to insert the data into this table, correct? Whereas same thing could have been done using a simple join. If I execute this, you will definitively see, for example, the loop takes a lot of time. Let's compare. They both return the same number of records. If you're looking at the loops take 5,744 milliseconds, whereas for example, the one without cursor, which is the join, take only 54 milliseconds. So that's mean it always best to know exactly what you want to achieve, right? Wherever possible, I would highly suggest you to use join instead of loop. I'm not sure how much time I have left. if I have to cut me on the demo.
No, you are fine. At least 11 minutes, but another session will start in another like 41 minutes. So you are fine.
Okay. And then if you're looking at also, even for functions, let me show you something here. What I'm doing here, I'm just checking if that index exists, drop it and create that index. Okay, and then I'm flushing my DB, my cache. Okay, and I'm about to query this one. As you can see, even though, for example, the index is created, it will not be able to use it because of the functions. Okay, and then whereas you could have done the same thing using less and equal, as you can see. This is exactly the same information. And just to show you that I'm not cheating, I'm clearing the cache. So now let me show you, for example, the difference. If you're looking at this one take 140 milliseconds, and then this one take 134. So that's kind of close. But if you increase the data set, so this is where you will see the magic. And that's the first time they get close. You know, when you're doing demo, it's always like that. But this used to be way more than this one. Yep. So now these are the different ways. And then there's a tons of other things. Let me go back to my slide deck that we can think of. There's a ton of other things. When you're doing performance tuning, one thing I want you to understand, you cannot only think of bringing the execution time down. If like I have a couple experiences with some of my coworkers where, for example, when they tune a process, they only care about how fast that query return, but they don't care about the resource usage. When you're doing performance tuning, there's two things you have to take in consideration. You want that process to use minimum resources, which is related to the resource usage. And also you want it to take very small amount of time that match business SLA. So for example, business processes, if you will, you cannot only take just to bring that execution time down from 10 minutes to 30 seconds, but during those 30 seconds, no one can access that database. Otherwise, you're gonna have a lot of timeout. There's gonna be a lot of, business will lose money too, by the way, right? So you don't wanna only think, you know, just bring the execution time down, just for your information. And then for tuning concepts is that cardinality estimation, you need, you guys can do some research. This is one topic by itself. Okay. And then there's query optimizer. When you're doing, when you're tuning a query, you have to understand, you know, a lot of things like the operators, the type of operators, you understand, and then you have to understand how to read that query plan, where to start, understanding the dimension of the path, how big, how thick, how much data, and there's so many things you can take in consideration. This is another session. And then if you are on Azure SQL, you can leverage automatic tuning, but not for every database application, because you have a better knowledge than automatic tuning. So that's where you want to maintain it. But in case if, for example, this is not something that can impact, you can leverage this as well. And then for intelligent query, this is another session. I would highly suggest you to do some research to understand, especially there's so much cool stuff on the intelligent query processing, like memory grant. There's a ton of other stuff. I would highly suggest you to go and do some research and learn it. We don't have time. I don't want to spend too much time. And then also, when it comes to testing consideration, if I know it's gonna be kind of impossible to test apple to apple when it comes to workload, but the resource has to be the same. That's one of the things I always say. If the resource is not the same, you think you optimize the process, and then yeah. So these are the things you will need to think of. So I'm gonna show you how normally when things happen, what I do, where I start. This is just my checklist. It works for me very well. It may not work for you, but you can modify it however you want. But I guarantee you, you're gonna like it. Anytime when things happen, first thing I start doing is troubleshooting live sessions, like blocking, open transaction, parameter sniffing. If, for example, that don't tell me anything, that's when I'm gonna think of resources. Like, am I having heavy CPU utilization, IO memory? What would be the issue? You understand? If none of them tell me exactly what I want, that's when I'm gonna think of error log, run my PowerShell script to go and do some analysis against SQL Server, agent, error log, and Windows event log, even application error log, if there is any. So if I cannot find anything, this is when I'm gonna think of analyzing the object like index and statistic. The reason why I start with this very late, because they are very expensive operation. They are not free. If you need information, this information will add a bit of overhead. And let's say if the issue is not related to indexes and statistics, not only you will waste time, and also you're gonna add more issue on top of issue, right? And then if I'm not able to find anything, if everything looks amazing, there's absolutely nothing that needs to be done. That's the time I will externalize the issue, because not every performance issue is related to database. It could be related from the client side application, right? There's so many things. And then that's the time I'm going to open a priority ticket and work with operation team, work with network team and application developer team to find out how can we resolve this. Because what I have seen is that most likely people think 100% of the time the issue is always database, and sometimes it is not, and there's absolutely nothing you can do. Even though if you restore the server, there's nothing you can do. So these are some useful DMVs that you guys can leverage and use. You understand? So to troubleshoot anything related to live query execution, that's what you can do. If you want to get the history more detailed, these are tons of DMVs. These are with start DMVs. These are statistic DMVs, and then CLR index, right? Thank you so much for attending my session. You guys, you want to connect with me, I'll be happy. Okay, and if you have any question, feel free to let me know. I'll be happy to answer if I can. Thank you.